Moments are rotational forces. So you have a force times a distance, just like you would with work, but the force and the distance are perpendicular to each other. And so we consider the counterclockwise motion to be a positive moment and the clockwise motion to be a negative moment. Okay, so we're showing here the right hand rule. That is a clockwise motion, therefore it's negative. But I wanted to jump into the two example problems and calculations. So the first one is here that you have a wrench. All right, so wrench should be something you're relatively familiar with using. You have a force of 20 pounds and you have a distance of 9 inches. Now, keep in mind that pounds and inches don't necessarily go together, so you're going to have to convert the inches into feet. Okay, so distance times force, right? Right hand rule says that that's going to be a negative moment. Okay, and so we convert our 9 inches into 0.75 feet, just 9 divided by 12, since there's 12 inches in a foot. Okay, so we take our 20 pounds times the 0.75 feet, and then we make it negative afterwards to determine that moment. So the correct answer there is negative 15 pound feet. Now, if it was going the other way in a counterclockwise direction, then that would be a positive moment. Okay. So if I have a longer wrench, all right, again, 20 pounds times 1 foot, and I'm going to do the same thing. Okay, now with an L-shaped wrench, all right, notice how the direction of force is perpendicular to the motion. So we make this imaginary line there in which we come over from the pivot point and up. So in that case, that distance is 3 inches. So remember, it's perpendicular, okay, still going negative. So we're going to use the 0.25 feet there instead of the 1 foot. Okay, I want to jump ahead now to the next example problem, which is the seesaw, because sometimes you have a situation where it's asking you to calculate what we call an equilibrium. So basically, an equilibrium is the force times the distance of one moment is going to equal the force times the distance of the second moment. So in the case of the seesaw, those two moments are going in opposite directions, as you'll see here in a minute. Okay, so you have two bears on the seesaw, all right? And one bear is heavier, therefore it results in a moment in that direction. Okay, so distance 4 feet and force 125 pounds. All right, so if I were to calculate that, okay, F1 times D1 is going to be 100 pound feet or foot pounds. Okay, force 2 is 40 pounds, but we don't know what the distance is. So we have 4 times 25 on one side. Sorry if I'm looking away, I'm writing off to the side here. And then on the other side, we have D2, which we don't know, times 40. So that becomes just a combine and multiply. So moment 1 plus moment 2 has to equal 0 if it's in equilibrium. Again, a positive and a negative. And it looks like that. So 25 times 4 minus 40 times D2. So if we divide 40 from both sides, 100 divided by 40 gives us an answer of D2 of 2.5 feet. So that's the example for situation or problem number 2. Again, as you go through the other practice problems on the assignment, make sure that you show your work.